Hi, you are welcome to today's lesson, Waec 2024 General Mathematics, Objectives number 13 and 14. Without wasting much time, let's dive into the lesson. Now in question 13, the question here says that a variable W varies partly as M and partly inversely as P. Which of the following correctly represents the relationship with K1 and K2 as constants? Now, the case we are dealing with here is a type of variation that is called partial variation. In partial variation, two constants are given, and then in relation with other variables, maybe two or three or more variables that the question wants us to relate with the constants. So in this case, we are having the two constants here as K1 and K2. So the way we treat partial variation is different from how we treat joint variation, direct variation, and inverse variation. But the idea we have from those types of variations can be put together to use to solve partial variation. So the question at hand, the question here says a variable W. We are going to write this W here first, so we can write it W. All right. So the variable W varies partly as M. So we put our equals to, write the first constant K1, give a gap, put a plus, give a gap, and write the next constant K2. All right, so this is the first thing we do. Now, in the question it says a variable W varies partly as M. So we come to this first constant. Since it varies partly, that means it is directly proportional to this first constant. So we'll write it here, M. All right, so we are done with the first part. Then the second part, it goes on from the question. It says, and inversely as P. So the second constant is going to carry the inverse of P. Inverse of P means that P is coming under this constant. So if we do this, we're going to write our P underneath here. And this is how we go about solving this question. So for W is partly constant with M and inversely proportional or inversely as the second constant K2, as you can see here. So if you check the options in this objective question, you will see it corresponds to option C, and here is the right answer. Now, without wasting much time, let's quickly talk about the next question. Now, in the next question here, we are told that a cylindrical metallic barrel of height 2.5 meters and radius 0.245 meters is closed at one end. Find correct to 1 decimal place the total surface area of the barrel. So in this case here, we are dealing with a solid shape, which is three-dimensional shape, and the shape is a solid cylinder. So what do we do in this case? First things first, let's draw the cylinder. The cylinder has a top circular part. Then we draw these two lines down this way, and we draw the second circular part. Now, according to the question, we are told that the radius is 0.245 meters. So the radius is the distance from here to the distance from here. So we have 0.245 meters. So that is the distance from here to the distance from here. That's the radius. Then also it has a height of 2.5 meters, which is the distance from here to here, 2.5 meters. Okay, so we have transferred some of the values given to us here into this diagram. So how do we answer this question? Now, the first thing we do is to draw the net of this this cylinder. If it's here, the net, if it's here, this cylinder open here, you are going to have a rectangular surface this way, and the circular base will be there. But let me hold on at this point and bring you back to the question. The question says a cylindrical metallic barrel of height 2.5 meters and radius 0.245 meters is closed at one end. You see, this is the key word here, closed at one end. What does that mean? It means this second top part here, the circular top, will not be drawn. We're only concerned with this part, which is the closed end, and of course the rectangular part that is here. Okay, so that's what we are going to be using to solve this problem. Now let's go over to this place. This is the circular part here, right? And the area of the circle here, of course, you know, is pi r squared. And this is the rectangular part. Before we talk about the rectangular part here, the height is h, and the length here is what goes around the circle. So it's the circumference of the circle, which is 2 pi r. So the area of the rectangle, which is a, will become length, which is 2 pi r, then multiply by the height. So let's put this formula together now. Don't forget the total surface area, okay, with one end closed. Now for us to get the total surface area, we use the formula of pi r squared, then plus 2 pi r h, 2 pi r h. Now I'm not going to use factorization to solve this problem. All I have to do here is to solve them part by part. Okay, so we'll put our equals to, I would like to keep my pi constant, so I'll write it out as pi multiplied by the radius. We take the square of the radius, 0.245, which is this value you see here for the radius, and we take it as the squared, then plus, we pull out our pi, which is this pi that is here, then 2 multiply by the radius, 0.245 multiply by the height, which of course you know as 2.5. Okay, so let's come to the next step here. The pi is still constant, so here we are going to use our calculator to get 0.245 squared. And here is the calculator. First thing we do is to turn it on, okay, and then we put our 0.245 squared, okay, 0.245 squared, and that will give us 0.060025. So we'll write that down here, 0.0600 then 25. That's the value we got from the calculator just now. Okay, then we put our plus, then here we multiply 2. You can say 2 times 0.245, then times 2.5. And what is the result? The result is 1.225. So we'll write it here, pi times 1.225. Okay, so at this point now you notice that the result here will give us 0.060025 multiplied by pi, that will give us pi, then plus 1.225 pi. So in this case we are going to add these two numbers together. All right, so what we'll do now is to come to a calculator. We have this already, so we have to do is to press our plus, then 0 point what we have, 0.600 okay, so we have 0.0600025. so we have our 25, and the result here will give us 1.285. so write it out, equals to 1.285. okay, 1.285 then 0.25, we'll write it out here, 0.25, don't forget the pi. Now, the question does not ask us to answer in terms of pi. So what we have to do here now is to take the value of pi, which is, we first of all write out these numbers again, 0.25, then multiply by pi is the same thing as 22/7, which if we divide, it will give us 3.142. So we are going to multiply these two together. But take note that pi is 22/7. And that's what we used to got this, okay? So now that means this answer we got here, we are going to multiply it by 3.142. And if we multiply it by 3.142, we have 4.035. So here we write equals to 4.03 then meters squared, since we are dealing with the total surface area. Okay, but now coming back to the question, lastly, the question says to one decimal place. Okay, so which means here we are going to put our final answer here to become to one decimal place. After this decimal point, we are considering 3 then 0. So this 3 is rounded down, so we cannot add it to this. So our final answer will become 4.0 meter squares then to 1 dp.